Hello friends, welcome back to VCP Technology. In this video, I'm going to teach you about arrays. So basically, array is nothing but a collection of elements of similar data type. Let me give you a brief clarity about array. Array is nothing but a variable. But there is a small difference between variable and array. A variable can hold a single element at a time, but an array can hold multiple elements at a time. Okay, in AS400, we have two types of arrays. The first one is compile time array and the second one is runtime array. First, let me create a program for runtime array. After that, we'll go for the compile time array. Okay, what I have told you before, array is nothing but variable, right? So now I'm going to declare a variable, okay, which is ARR. This is called variable declaration, right? So if you want to declare a array, you need to initialize the array as like a variable. Along with that, you need to add an extra keyword which is dim, dimension, and you have to mention how many variables do you want in your array. This is called array declaration. Here I have initialized the array with some values. After that, I'm going to print those values by using for loop. Okay, now I'll tell you how this for loop will execute. Initially, I'm initializing the I value as 1. It will check the condition. 1 is less than or equals to 5, right? Condition is true. Then it will come inside the for loop. It will print the array of 1. Here I value is 1, right? So ARR of 1. What is the ARR of 1? 10, right? So it will print 10 first. After that, I value will be incremented by 1, which means 2. 2 is less than or equals to 5. Condition is true, right? Then it will come inside the for loop and it will display the array of 2, okay, which is 20. After that, I value will be incremented by 1, which means 3. 3 is less than or equals to 5. Condition is true. Then it will come inside the for loop. It will display the array of 3, which means 30. After that, I value will be incremented by 1, which means 4. 4 is less than or equals to 5. Condition is true. Then it will come inside the for loop. It will display the array of 4, which means 4th element. After that, I value will be incremented by 1, which means 5. 5 is less than or equals to 5. Condition is true. Then it will come inside the for loop. It will display the 5th element. After that, I value will be incremented by 1, which means 6. 6 is less than or equals to 5. Condition is false, right? Then it will come out of the for loop. After that, this will end the program. Now we'll file this and compile this. We'll see the output. Call it 10, 20, 30, 40, 50. We have another method to initialize an array. Now I'll tell you about that. We can initialize an array by using list function. Okay. For that, array equals to percentile list of. I have to give the elements by separating them with colon. Okay. So this is how you have to initialize an array at a time. Here this list function will take multiple arguments at a time and those will be stored in our array. The element which you given first, that will be stored as an first element in the array. The element which you given as second in the list will be stored as a second element in the array. The element which you give third element in the list will be stored as the third element in the array. Like that, all the values will be stored as per the given order into array. Now we'll file this and we'll see the output. Call this 10, 20, 30, 40, 50. Okay. Here, instead of giving the size directly, you can use the percentile element function. This percentile element function will take automatically the size of the array, and this loop will be repeated up to the size of the array. Okay. Now we'll file this and we'll see the output. Call it 10, 20, 30, 40, 50. So this is the output which we got previously. Okay. Now we'll move to the compile time array. So compile time array is similar to runtime array. How do we initialize the runtime array? Declare yes standalone ARR is zone type of 2 with the dimension of 5. This is called runtime array, right? If you want to declare a compile time array, you just need to add 2 more keywords for this declaration, which are CT data, which means compile time data. After that, per record, I'm going to give 2, which means when you are initializing the compile time array, you have to give 2 values per a line. So that is the meaning of this per record. So for compile time array, we have to initialize that array at the last of the program. Okay. Here you need to mention these 2 stars first. After that, you have to write a CT data keyword. After that, the array name. Then you have to mention the values. Here you can observe that we have two values for a record. If you mentioned 3 or 4 records, then the compiler will not consider about them. You may get a doubt that how can a compiler get to know that these are two values. So the compiler will go to the array and it will check the size of each element. The size of the element is 2, right? It will divide the 2 digits as a element. After that, the next 2 digits will be considered as another element. So like that, the compiler will divide the given values. Okay, now we'll file this and compile this. Call it 10, 20, 30, 40, 50. So we got the correct output, right? Now let me move to some inbuilt functions which are useful in arrays. Okay, these are the inbuilt functions which we have in arrays. There are some more inbuilt functions, but mainly we are using these inbuilt functions. Okay, I have told you about the percentile element function already and the percentile list function also. Now I'll tell you about the sort A, which means sort array. So this is the program for sort array function. First I'm declaring the runtime array as usual. After that, I'm just adding a new keyword which is ascend. This will arrange the given values into a ascending order. If you mention descending over here, the values which you given for array will be stored as an descending. Okay. Here I have displayed a message which is before sorting. After that, all the values will be printed before sorting as usual, which we stored over here. After that, I'm sorting the array. Again, I'm going to display the another message which is after sorting. After that, I'm going to display all those values. Now we'll file and compile this. We'll see the output. Before sorting 50, 30, 10, 20, 40. After sorting 10, 20, 30, 40, 50. Now we'll change the keyword. Here I just changed the keyword which will affect the result in descending order. Okay. Call it before sorting 50, 30, 10, 20, 40. After sorting 50, 40, 30, 20, 10. Okay, this is how you have to sort an array. Now we'll move to the next function. Percentile lookup function. This percentile lookup function is used to search a particular element in an array. Okay, so this is the program for percentile lookup function. Here I have declared a runtime array. After that, I have taken one more variable which is used to store the position of the particular element. After that, I am initializing the array with percentile list function along with some values. After that, I am going to searching for this particular element in this array. This percentile lookup function will take 2 arguments or 3 arguments. The first one must be the element which we are going to searching for. After that, the second one must be the array, and the third one is optional. If you mention the third one, that will be the initial position. Okay. So here we go. We got the position as 2. So in the array, we have initialized the values from 10 to 50, right? So in that array, the position of 20 is 2, right? So that's why we got the position as 2. Now we'll see about the third argument. Okay. Here I have mentioned the third argument, which is the starting position. Okay. Which means this lookup function will start the searching for this element in this array from the third position. If it is found from the third position, it will give you the position of the element. Otherwise, it will give you 0. Now we'll file this and compile this. We'll see the output. Call it 0, right? So we got the position at 0 because the value 20 was there at second position, right? We are searching from the third position. That is why the compiler gives us the position as 0. Okay, which means that is not found from the third position up to end of the array. Okay, now we'll move to the next function, percentile export function. This percentile export function will give us the sum of the arguments in the array, which means it will add all the elements in the array and give us the final result. Here I have declared a runtime array. After that, here I have taken one more variable which is used to store the summation of all the variables which are present in array. After that, I'm initializing the array with some variables. After that, we have this line, right? So here %export function will take only one argument, and that should be the array. It will add all the elements which are present in array, and it will give the result as the summation of those variables. And we are going to store that value in a variable called sum. After that, I'm going to display the sum of the variables, okay, along with some text. Now we'll file this and we'll see the output. Call it 150, right? Here 10 plus 20, 30, 30 plus 30, 60, 60 plus 40, 100, 100 plus 50, 150, right? That is why we got the summation of array as 150, okay? This %export function can also be used to sum the two arrays. Now I'll give you the example of that, okay? So here I have declared two arrays. After that, I'm going to initialize both arrays with some values. After that, I am using this export function to sum these two arrays. Now we'll analyze the output of this export function. We already know the sum of this array, right? So which is 150. After that, the sum of the second array is 15, right? Now we'll file this and compile this. We'll see the output. Call it 165. Correct, right? The sum of the first array is 150 and the sum of the second array is 15, right? So 150 plus 15 is 165. That is what we got here. Now we'll move to the next function, which is percentile subarray. So this percentile subarray will extract some particular elements from a given array. Now we'll see a program for this. So this is the program for subarray. Here I have taken two runtime arrays. After that, I have taken one variable which is used for loop. Okay. Here I have initialized the array with some values. After that, I'm going to display all those values which are present in the array. After that, I'm extracting particular elements from the first array into second array, which means this percentile subarray will extract the elements from the second position to fourth position in the given array. Which means this percentile subarray function will take three arguments, which are first one must be the array, and the second one is the starting position, the third one is the ending position. This will extract the elements from the starting position to ending position from the given array into another array. After that, I am displaying the second array elements. Now we'll file this and compile this. We'll see the output. Call it original array elements are. So these are the original array elements, and these are the elements which are present in subarray. Okay, we are extracting from the second position to fourth position, right? This is the original array, right? Here the second position is 20. From the value of 20, we are going to extract up to fourth position, which means up to 40. It will extract the subarray as 20, 30, 40. So this is the output which we got over here. So those are the arrays concept. So that's it for this video. I hope you understand this, guys. Thanks for watching. See you in the next video.